Welcome back. This is Mr. Hassan's Maths channel, and this is question number 11, part 2 from the October-November 2014 Cambridge A-Level, International A-Level 9709, paper 1, variant 1. This is a pure math paper, and this question here is about area between curves, the area between curves. So here we're asked to find the area of the shaded region. As the area enclosed between these two curves, y equals 4x plus 1 to the power of a half, and y equals a half x squared plus 1. And we already know the points at which they intersect. So that's one job that sometimes we're asked to do, which is already done for us. So we know where they intersect. So in that case, we know if we are going to find the area, okay, by considering the area between these curves and the x-axis, we have the limits from 0 to 2 already there. Okay, so basically what we're going to be doing is we're going to be finding the area under this curve, which is the area under the curve 4x plus 1 to the power of a half with respect to x. If I integrate this between these 2 points, it will tell me the area under this curve. I'm going to take away from that the area under the other curve, which is below it, between 0 and 2 again, and this is a half x squared plus 1 with respect to x. So if I find the area under this curve, okay, this will tell me the area all the way down to the x-axis between 0 and 2, and this will tell me the area under the other curve between 0 and 2, and that will give me the area between them. Alternatively, what I could do is I could just take this as one step and just find the area between them by subtracting the two equations, in which case I'll get something like this, and then when I integrate, I'll find the area of all those sections from there to there. Okay, so I could actually combine this into one integral, and that would be 4x plus 1 to the power of a half minus, and then this, which is going to be minus a half x squared, and then minus 1 will give you minus 1, and integrate that with respect to x. So I'm subtracting these two equations from each other, okay, and then integrating between those same limits 0 and 2. That will give me the area between the two curves, between those 2 points 0 and 2. So now I need to integrate these two, or this whole expression. So I can integrate these terms separately. Now the first term here, 4x plus 1 to the power of a half, is a case of what's called, you can say, reversing the chain rule, because you can see here that you have a whole bracket raised to a power. So it's something inside the function raised to a power. So if we can see this as a result of the chain rule having been applied, then what's outside, what's multiplying this bracket, should be of the same kind of type as the differential of what's inside the bracket. So if you differentiate what's inside here, you get a constant. What's multiplying outside this bracket is basically 1. Okay, so constant. So this is of the same type of the reversing the chain rule. So we can reverse the chain rule, and we can write this as 4x plus 1, and now we add 1 to the power, so that becomes 3 over 2. A half plus 1 is like a half plus 2 over 2, which is 3 over 2. Then we divide by the new power, but then we also divide by the differential of what's inside this function, which is 4. So we divide by that 4, and then we have that's basically integrated this. We can simplify this on the next step. We integrate this as well. You have a half, and you're going to raise to the power of 1. So we can raise this x to the power by 1. That becomes a half x cubed, divide by the new power 3. And the constant 1 just gains x, so it's 1x. And we have now integrated this. So I didn't write this with the integral sign anymore. I write it with the brackets. So I have 0 and 2 as my two limits. Now let me simplify all of this before I actually substitute the values in to make it a bit simpler. So this is going to be, let me write that a bit more like here. So now you're going to have 2 and the 4 cancelling, leaving with 2, so it's 6. So you're going to have, this is the cube of 4 plus x to the power of a half. So this is basically the square root of 4x plus 1 cubed. Okay, the numerator is the power and the denominator is the root, over, and you have 3 times 2, which is 6, minus, this will be x cubed over 6 minus x. So now when I put these values of 2 and 0 in here, I should get the answer required. So let's put 2 in here first. So you have the square root of 4 times 2, 8 plus 1, which is 9. So that's 9 cubed. So make that a bit smaller. So it's the square root of 9 cubed divided by 6 minus 2 cubed, which is 8 over 6 minus 2. And then I'm going to take away what I get when I put 0 in here. Now, a lot of people don't bother putting the 0 in, but there are some expressions. I mean, because, for example, this becomes 0, this becomes 0. They assume everything will become 0, but look at this expression. It won't become 0. When you replace the x here with 0, you'll have 4 times 0 plus 1. So you'll end up with the square root of 1 cubed, which is 1 over 6. So we would have messed up the question if we just assumed that 0 will make everything 0. So be very careful about that. And, don't make that mistake. So we have the square root of 9, which is 3. 3 cubed is 27. So you have 27 over 6 minus, I'm going to keep everything over 6 because I need to combine these fractions together. So I'll keep them the same denominator. In fact, I'll make minus 2 into 12 over 6. And I have 1 over 6. That way I can keep the same denominator, which is 6. So 27 minus 8 is going to be 27 minus 8 is going to be how much? That's 15. Okay, 15 minus 1 is 14. Is that right? And 14 minus 12. 27 minus 8, that's 19, sorry. 19 minus 1 is 18, minus 12 is 6. That's right. So 27 minus 8, that's 19. 19. 19 minus 12 is 7. 7 minus 1 is 6. So it's 6 over 6, which gives us 1. Okay, so there we have the answer. So the area in that shaded region is 1 square unit. And there's a way we can check our answer to make sure. And that is to take this expression here, and we can actually put it in our calculator and see if we get the correct answer. We can actually do this by using this button here. So I'm going to put it in as it is here. So I'm going to have here 4x. So you use this x over here. 4x plus 1, close brackets, to the power of a half. So put it in before you integrate it, of course. To the power of a half. Okay, and I'm going to have minus a half x squared. And then going to have minus 1. Close that bracket. I'm also going to put another bracket on this side to keep everything in that one bracket. So I'll put a bracket here. And then I'm going to put the limits in, which are 0 and 2. 0 and 2. Now this, if I've typed everything correctly, should give me 1. And it does. So, of course, we can't just write 1 as an answer and stick this all in the calculator. But what we can do is with the calculator check to see if we got the right answer. So showing these steps is vital. Showing that you integrated them, that's all part of the marks. I think there's about 6 marks on this question. Okay, in total. Yeah, so this part of the question. So showing all these steps that you've integrated it and that you've put the values in are necessary. But in the exam, if you have time to check, it's a very good, useful tool to have. Otherwise, I mean, sometimes it's very, very easy to make silly mistakes in this question. When you are, dealing with signs, as I said, like, for example, forgetting to put the 0 in, okay, things like that. It's very easy to make a silly mistake. So this is a way you can rest assured that you haven't made a mistake. And if you have got it wrong, you can go back and check your answers, which is another reason why it's good to keep your steps nice and clear and methodical, so you can check your steps very easily when you are going back through the question. All right, so that completes question number 11, part 2. 11, part 1 will be found with the rest of the questions that I have answered from this paper, if I get to answer them eventually, in the playlist that I have prepared, which is linked in this section over here. At the end of the video, you can click that link. The link at the bottom of the page will take you to questions that I'm dealt with integration from P1 of Cambridge. And you can subscribe to my channel by clicking this link over here, and the video at the top here will show you how to use my channel to find what you're looking for in an efficient manner. Thank you for watching, and see you soon.